For this part, we're going to be working with addition and subtraction of radical expressions. The nice thing about this topic is that it's nothing new, really. If we have, for example, the problem 3 times the square root of 2 minus 5 times the square root of 2, the whole problem becomes just looking at whether or not we have like terms, and like terms in this case with radicals is determined by whether they have the same radical to the same index. In this case, both of these terms have a square root by simply using the distributive property or by factoring out a radical 2. And so if we factor the radical 2 to the outside, we can think of the first term left inside the parentheses would be a 3, the second term left inside the parentheses would be a negative 5. So that gives us a negative 2 square. These things are minus 2 of these things. So it's, again, a situation of combining like terms. Let's look at another example. Suppose that we have a negative 2 times the square root of 48 plus 3 times the square root of 75. Now, the first thing we're going to do with this problem is simplify each radical. Now, we know that 48 is the same thing. Since we're taking square roots, we want to see what perfect squares are inside. And so we know that 48 is the same thing as 4 times 12. Let's leave the other radical for a moment and just work with this. Well, we have 4 times 4, that's a perfect square, so we know that that can come out to the outside. So we'll have a 4 on the outside, the square root of 3 remains on the inside. So the first radical becomes a negative 8 times the square root of 3. Let's look at the second radical, 75. What perfect square is a factor of 75? Well, we know that. We know that 75 is 25 times 3. 25 is a perfect 5 to the outside. So outside the radical, we're going to have 3 times 5, and we're left with the square root of 3 inside the radical. So finally, that second term becomes 15 times the square root of 3. And once again, using saying we've got like terms, they're terms that contain a radical, the square root of 3. So if we have minus 8 of these and plus 15 of these, we really have 7 of these, 7 times the square root of 3. And again, remember, all that I'm saying is just a shortcut to the distributive property. But we have to have the same radical to the same index in order for us to have like terms and to be able to combine them. Now, what if we have some variables inside? Suppose we have 8 times the square root of 2x. Well, the problem's no different if we have variables inside the radicals. We don't know what those variables are, so we can't do anything with the variables in this case because it's x to the first power, but we can certainly take to the outside whatever is possible in each of the terms. For the first term, there's nothing to take to the outside. But the second term, since it's 4 times 2, we can remove the 4 to the outside. It becomes a 72, the square root of 72x. Well, let me rewrite that as a 9 times 8, but 8 is 4 times 2, so we can say 9 times 4 is 36 times 2 is 72 times x. Okay, so from this last radical then, we can remove the 9 to the outside. It becomes 3 on the outside. Then we can remove the 4 to the outside. It becomes 2, and we're left with the square root of 2x. Okay, so that last term then is a plus 6 square root of 2x. But we still have the other terms here, 8 times the square root of 2x minus 2 times the square root of 2x. Again, you can think of these as 8 of these 6 of these things, so we'll have 12 of those. But remember, if that's a little bit confusing, we can certainly the outside and just do it directly. If we factor out the square root of 2x, we'll have 8 for our first term, we'll have a minus 2 for the second term, and a plus 6 for the third term. So we have 6 plus 6, that's 12 times the Now, in this case, let's look at another problem. Suppose we have a negative square root of 27 plus 3 times the square root of 72 minus 7 times the square root of 50. Okay? Let's simplify each radical first. Square root of 27 contains a 9, so we can take the 9 to the outside since the 9 is a perfect square. And so we're going to have a negative 3 on the outside, but inside the radical we have a 3 left since 27 is 9 times 3. The 9 comes outside, the 3 stays inside. 72, we've seen this before, that's 36 times 2. 36 is a perfect 6, and we're left with the square root of 2 inside. 36 times 2. The 6 comes out, the 2 stays inside. How about 50? Well, since it's a perfect square, it'll be 5 on the outside, and we're left with the square root of 2 inside. So what do we have now? We have minus 3 times the square root of 3 plus 18 times the square root of 2 minus 35. Is not a like term to the other two quantities, and so we can't combine it, but we certainly can combine these two. Here we've got a plus 18 and we have a negative 35. Together they will give us a negative 17 square root of 2. The first term remains as a negative 3 square root of 3. So the simplification in this case yields a negative 3 square root of 3 minus 17 square root of 2. And since we have different radicals, there's not. The problem is the same if we work with radicals that have a higher index. For example, suppose that we have 3 times 2 minus 5 times the 4th root of 162. Okay? Now we're working with 4th roots. What we want to do is find perfect 4th roots. Is a factor of 32 is 16. So 32 is the same thing as 2 times 16 because the square root of the 4th root of 16 is equal to 2. For 162. Well, that may be a little bit harder to see, but it's an even number, so we know we can write it as 2 times something. 16 divided by 2 is 8. 2 divided by 2 is thing as 9 times 9, right? And 9 is the same thing as 3 factors. That means that this is a perfect 4th power. And because it's a perfect 4th power, it can go to the outside of the radical. Move this perfect 4th factor 4th power to the outside, and it becomes a 3 on the outside. Inside, we're left with a 2. Well, I wrote this a little bit in a weird way, I think. So let's combine that. This is negative 15 times the 4th root of 2. On the outside, so we have 3 times 2 times the 4th root of 2. So for that first term, we have simply a 6 times the 4th root of 2. But now we're working with 4th roots of 2, so these are like terms. Combining these, we've got 6 of these and minus 15 of those. That gives us a negative 9. So the problem is similar to the other problems.